In this video, what I want to do is build inside of LogicWorks our up and down counter that we developed in class. So on your screen you see an up-down counter that has the most significant bit over here C, the least significant bit over here A, and D means that we are counting upward, or sorry, counting downward. U means we are counting upward, and those counts will occur on a common clock. And so what I will do is try to put this over off the screen a little bit, and I will make LogicWorks fill up hopefully the rest of the screen, and we will work on building this. So let's begin with our flip-flops. In this case we're using D flip-flops. And so we have a few options here. We have this one with the set and the reset that has Q and Q prime. Remember, we have this one that just has a reset, but it does have an enable. It only has Q out. We have this one with Q and Q prime with the non-inverting set and reset. We have this one that just outputs Q with a D and a C with no reset on it. And then we have this with a D, C, a reset, and a Q. Now, since we would like to use our Q prime, we have A prime and B prime involved. Let's pick one of our flip-flops that has an R and an S input. So I'm going to pick the one with the non-inverting. And so I'm just going to put those across the screen here. And so these will be rotated a little bit relative to what we have on the left-hand side here. We can actually rotate these to the left if you would like, and so that will make things look more like what we have on the screen. So in this case, our Q is coming out here and our Q prime is here, so that's a little bit backwards to what we see over here. Let's see if we can flip that. Yep, we can flip it horizontally, and that way this will now look more like our example that we have over here. Now, you'll notice that this logic does not have a reset on it, although it would be nice to have a reset to take our count back to 0 at any given point. We don't need a preset on anything. So what I'm going to do first of all is go ahead and put a ground signal into all of the S inputs. So here's a ground into that S, ground into that S, ground into that S. And the reset, I'm going to put a binary switch. So I'm going to put binary switch here, and this will be our reset. So let me name this as reset. And this will take our count back to 0, and I want to make this a common switch for all three of the flip-flops that we have. So there, I'm going to tie it to that one. I'm going to come down here, tie it to this one, and then I'm going to come over here and tie it to this one. Now, one thing that I want to make very clear is which of our flip-flops is designated as C, which one is designated as B, and which one's designated as A. What you'll notice is all of them just have Q and Q prime. So I'm going to go ahead and put some binary probes on here, here, and here. And I'm going to pull them up a little bit. So those will come up higher. So our count will just stay up at the top. And you'll notice our count starts out as an unknown because we have not activated our reset. We've not clocked in anything. I'm going to give this a name. This will be the C probe. This will be the B probe. And this will be the A probe. Okay. And now I will put our common clock So I need another binary switch right here. And I'm also going to put another binary switch, one for the U and one for the D. Okay, so this is going to be my clock. So I'll just put CLK. And then this one I will name as U. And this one I will name as D. Okay, so now let me go ahead and attach my common clock to all of the C inputs that we have there. So there's a common clock. Here is a common clock. And then over there is a common clock. So all three of the flip-flops are driven by the same clock. We're just going to use this binary switch as a clock. And now it's a matter of implementing the logic that we see here. And so in your project 1, I didn't allow you to use discrete logic gates. Now I will. Okay, and so in this case, let's look for an XOR. And that's our exclusive OR, and we want one that has two inputs. So each of these is going to be needed. So we'll put one here, and I'm going to rotate that to the left. So here's my first one, and let's see if I copy it. Now I don't have to rotate every one that I get. So I've got that, and I've got that. So each of these are driven by an exclusive OR. I'm going to go ahead and just pull this down so that we see that that doesn't have a node connecting to any of the reset logic or any of the clock logic. And so we have this, and let's go ahead and implement our A right here. So this is D or U. So let's go ahead and find an OR gate, and we want a 2 input OR. So there's OR 2, and so we've got that, and we are ORing that with or exclusive ORing the output of D or U with the current output A. So let's go ahead and take our current output A and feed that into our exclusive OR. And let's see if that did not get a complete connection. Let's fix the wire right here at the end. Now we've got a complete connection. And now let's do our D or U. And so I'm going to do the D signal first, run that on over here to this, and then I'm going to do the U signal, and I'm going to run this on over right to there. So now I've got my A logic taken care of. Now let's look at our B. And so once again, the exclusive OR takes as one of the inputs the current output. So there is our B, and then we need another 2 input OR. So there we go, and our logic here is D and A prime, or U and A. Okay, so we are going to need a 2 input AND gate, 2 of them. So let's look for AND 2, and so we're going to need one here and one there. And so let's go ahead and connect our AND gates, and in fact, just to make room, I'm going to pull this wire down out of the way, slide this up some. Okay, and I'm going to put that there, and that there. And so this one needs to tap off of our D, which is the bottom one. So there we go with D. This one is tapping off of our U, which is this top wire right here. And then we are ANDing D with A prime. So let's go and get our A prime. So A prime is going to come right out of here. This is our Q prime out of the flip-flop we've designated as A. And so I'm going to bring that on down. Let's make sure that made a solid connection. And then we have U and A. Okay, so let's go ahead and pull in A right here. And so we've got this connection. And I'll just pull this on down, pull this on down, cross that over, and we go on up. So those are our connections for the B logic. And now let's go ahead and connect our C logic. So here we are going to once again take our current output, drive that down, and that's going to be our first input into the exclusive OR. Our second input into the exclusive OR is going to be an OR 2 again. So we need to pull in 2 input OR. So there we go. And now we need 2 3 input ANDs. So let's go ahead and get an AND 3. And we need 2 of those. So we've got that. And let's connect their outputs into the inputs here. Connect their outputs into the input here. And let's follow along. We need D. So let's go ahead and pick up our D on the left side here. So that is our bottom one. And then we'll pick up U for right here. And then what is ANDed with the D? Well, let's trace this back through. It's actually the same thing that we ANDed with D before, which is our A prime. And so we can actually just bring this connection on over. Okay, let's make sure that's all nice and connected. I'll try to straighten up that wire just a little bit. So we've got D and A prime and B prime. Okay, so I need to pull in my B prime, and so I can just go down this way, connect across, go on up. Okay, so we've got that. And then on this side we've got U, and we trace this connection on up, U and A. So just like before, we had already brought A down to here, so we can connect that on over to, I'm just going to put it on this side. And then our other connection is to B. And so here is our B. And I'll just bring that on down. And there we go. So let's test to see how well this works. So I'm going to click to the arrow so that I can actually actuate these different values. And so the first thing I'm going to do is I'm going to reset it. So that's a good sign. Everything went to 0 on reset. Now if I leave my U and my D in 0, that shouldn't count at all. It should just hold those values. So if we count upward, 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 nothing. So now let's count up. So we should see it count from 0 to 1 to 2 to 3 in binary. So there's 1, 2, 3, 4, 5, 6, 7, and then it should roll back to 0. So our upward counting is working fine. That's very good. Now let's see if it counts downward properly. So I'm going to turn off U and turn on D, and now we should see it go from 0 down to 7, then to 6, 5, 4, all the way back to 0 again. So 0, there's 7, 6, 5, 4, 3, 2, 1, and back to 0 again. So that means we didn't make any mistakes in implementing our upward and downward counter. Now, just out of curiosity, what would happen if we were to turn on the D and the U at the same time? Remember, this is not allowable. Let's just go ahead and, out of our own curiosity, see what happens. So we're at 0, 0, 0, then it goes to 7, then it goes back to 0, and so really nothing useful at that point. Alright, so we'll go ahead and reset it, and we'll stop the video right here.